Before we get into starting to talk about saturated fat, cardiovascular disease, lipid patterns, and the cholesterol heart hypothesis, we need to begin with something very simple. What is cholesterol actually? Because for most people, cholesterol has become a fear word. It's something that they've been taught to associate with danger, clogged arteries, heart attacks, and bad labs. But before we can decide whether cholesterol is ever part of a problem, we first have to understand something much more important. Why does the body make cholesterol in the first place? Because if the body is making something on purpose at scale every single day, then it probably deserves more respect than fear. And that is exactly how I want you to begin thinking about cholesterol. So let's start with this. Cholesterol is not a toxin. It is not a contaminant. It is not some random harmful substance floating through the bloodstream causing trouble for no reason. Cholesterol is a vital biological molecule. It is something the body uses intentionally, constantly, and strategically. And one of the most important mindset shifts in this entire module is this: the body does not manufacture useless, dangerous molecules by accident. And that is a very important principle because cholesterol is not an error, it is part of normal human physiology. In fact, your body makes cholesterol every day. Most of it is produced by the liver, although other tissues can make it as well. And that matters because it tells us something important. Cholesterol is not just something that you eat, it is something that your body actively produces because it needs it. That means cholesterol is not simply a dietary issue. It is part of the body's internal economy. And this is one of the biggest misunderstandings in modern health conversations. People often think if cholesterol is bad, then why would the body make it? Exactly. And that is the right question because the answer here is this: the body makes cholesterol because cholesterol is essential. So, what does cholesterol actually do? The answer is a lot. Cholesterol plays major roles in cell membrane structure, hormone production, bile acid production, vitamin D synthesis, brain and nervous system function, and tissue repair. So let's break it all down. Let's talk about cell membrane structure. Every cell in your body has a membrane, a protective outer layer that helps regulate what comes in and what goes out. Cholesterol is one of the key structural components of that membrane. It helps maintain integrity, flexibility, stability, and function. So, right away, cholesterol is part of your basic cellular architecture, and that's a big deal. Let's talk about hormone production. Cholesterol is also a precursor to your steroid hormones. So, that includes hormones like cortisol, estrogen, progesterone, testosterone, and DHEA. So, when we talk about hormones, we are talking about something that is built downstream of cholesterol, which means cholesterol is not separate from endocrine health, it's part of it. Cholesterol is also used to make bile acids, and bile is essential for digesting fats, absorbing fat soluble vitamins, and supporting normal digestive function. So, cholesterol is deeply involved in the digestive system as well. Again, it's not random, it's not useless, and it's not inherently dangerous. Let's talk about vitamin D synthesis. Cholesterol is also involved in the production of vitamin D. And vitamin D is not just a vitamin, it behaves more like a hormone in the body. It influences immune function, bone health, mood regulation, inflammation, and metabolic health. So, cholesterol is connected here as well. Cholesterol is especially important in the brain and in the nervous system. Your brain is rich in cholesterol, and cholesterol plays important roles in neuronal structure, signaling, and nervous system integrity. So, when we talk about cholesterol, we are also talking about brain function, cognition, and neurological resilience, and that matters. And then finally, let's talk about repair and resilience. Cholesterol is involved in our repair mechanisms. It is part of the body's broader structural and restorative economy, which means when tissues are stressed, damaged, or under repair pressure, cholesterol often becomes part of the body's response. And this is going to matter a lot later in the module when we talk about cardiovascular disease. Because one of the biggest mistakes in the cholesterol conversation is that people often see cholesterol at the site of damage and assumed it caused the damage. But as we'll discuss later, sometimes cholesterol is part of the response, not the original problem. And that is a very important distinction. Now, cholesterol does not just float freely through the blood by itself, it travels as part of a transport system. This is where lipoproteins come in. And you've probably heard terms like LDL, HDL, and maybe VLDL. These are not types of cholesterol in the strictest sense, they are transport vehicles. They help move cholesterol and other lipids through the bloodstream. This is important because it helps us stop thinking in cartoon terms like good cholesterol and bad cholesterol. That language is too simplistic. A more intelligent way to think about it is this: cholesterol is cargo, and lipoproteins are the transport vehicles. So once we understand what cholesterol actually does, we begin to see why simply fearing cholesterol is not a very intelligent framework. Cholesterol is involved in structure, signaling, hormone production, digestion, nervous system health, and repair. So, if cholesterol is found in a place where the body is under stress, we should at least be willing to ask, why is it there? Instead of automatically assuming it must be the cause. That is a much more mature and physiological accurate question. And that mindset will matter a lot as we move through the rest of this module. Because once you understand cholesterol as a useful biological molecule, you are much less likely to interpret it through fear alone. So, what is this lesson really trying to teach you? It's teaching you to start from a more intelligent premise, not cholesterol is dangerous until proven otherwise, but rather cholesterol is essential and must be interpreted in context. And that is a very different starting point, and it is a much better one because when you begin from respect for physiology, you become a better interpreter, a better teacher, and a better coach. So if you remember one thing from this lesson, let it be this: cholesterol is not a toxin. It is an essential biological molecule. The body makes it on purpose, it uses it strategically, and it plays major roles in structure, hormones, digestion, brain function, and repair. So before we can ask whether cholesterol is ever part of a problem, we first need to understand why the body depends on it in the first place. And now that we've established that foundation, we can move into the next question: where does the heart health hypothesis come from? And that is where we're going next. See you in the next lesson.